It's surprising that the Tesla Semi still has so many critics, especially considering it offers the longest driving range of any electric truck in the world while operating at an estimated cost of just 15 cents per mile. That's a level of efficiency traditional Class 8 diesel trucks simply can't match. Some of the skepticism likely comes from Elon Musk's ambitious promises and the multiple delays that slowed the project's rollout. Now, however, the Tesla Semi appears to be entering a new phase with two major upgrades since reaching real-world production. The first is the development of full self-driving (FSD) technology specifically for the Semi, and the second is a redesigned cab aimed at improving efficiency even further. The idea of a massive freight truck driving itself on public highways is already generating heated discussion. If you're new to the channel, be sure to subscribe and turn on notifications so you don't miss future updates. The Tesla Semi isn't an ordinary vehicle. It's significantly longer and heavier than a passenger car, has larger blind spots, carries tremendous momentum, and often pulls a fully loaded trailer. A single mistake could have serious consequences. That raises an important question. Can autonomous driving actually make a heavy-duty truck safer and more efficient? At first, the concept of a fully self-driving semi-truck may seem unrealistic. The potential risks appear enormous. However, Elon Musk has repeatedly suggested that the Tesla Semi would eventually gain full self-driving capabilities, even describing it as a vehicle that could become a money machine for fleet operators. Based on recent developments, that vision appears to be moving closer to reality. Musk has even stated that Tesla could eventually produce more than 1 million semi-trucks, and that autonomous capability would become one of their defining features. So, how is Tesla developing FSD for the Semi? Recently, a Tesla Semi was spotted near Fremont, California, equipped with a large validation system mounted on its roof. According to available information, this specialized equipment is designed to collect highly accurate real-world environmental data through a process engineers call ground truth validation. Although the term sounds technical, the idea is fairly straightforward. Whenever a Tesla is driving, its cameras and AI continuously analyze everything happening around the vehicle. The system detects lane markings, nearby vehicles, traffic signs, road markings, motorcycles, pedestrians, barriers, curves, merging traffic, shadows, and many subtle details that even experienced human drivers may overlook. But to improve the AI, Tesla needs a way to verify whether its system is interpreting the environment correctly. That's where ground truth validation becomes essential. The roof-mounted equipment records the surroundings with even greater accuracy than the vehicle's onboard sensors. Engineers can then compare the AI's interpretation of the road with what actually existed in the real world. If the system mistakes an object, misjudges distance, incorrectly identifies a lane, or reacts too slowly in certain situations, the collected data helps engineers refine and improve the software. With the Tesla Semi, though, the challenge is much greater than it is with a passenger vehicle. Unlike a Model 3 or Model Y, the Semi is a Class 8 tractor capable of hauling a combined weight of up to 82,000 pounds. Its size, weight, momentum, longer braking distance, and larger blind spots make every driving decision far more critical. Even a small mistake can have much more serious consequences. Imagine a passenger car suddenly braking in front of the truck, another vehicle merging too closely, a slippery section of highway, a short entrance ramp, or a trailer beginning to sway. In every one of these situations, the Semi's autonomous system must recognize the danger and respond even more quickly and accurately than it would in a standard passenger vehicle. A minor steering adjustment that safely avoids an obstacle in a sedan could have a completely different outcome for a fully loaded semi-truck. The same maneuver might cause the trailer to swing or become unstable, creating a much larger safety risk. That's one reason why the recent sighting of the Tesla Semi carrying a ground truth validation system has attracted so much attention. Public opinion remains divided. Some people see autonomous trucking as a major leap forward in transportation technology, while others remain skeptical and concerned about the potential risks. Tesla has made significant progress with full self-driving over the past year. Many Tesla owners have shared experiences in which they believe FSD helped avoid accidents that might otherwise have occurred. Tesla has also released safety data indicating that vehicles using FSD experience one serious crash approximately every 5.3 million miles, compared to roughly one every 660,000 miles for human drivers. When it comes to heavy-duty trucks, the importance of improving safety becomes even greater. Every year in the United States, between 4,500 and 6,200 fatal crashes involve heavy trucks. In many of those tragedies, it isn't the truck driver who loses their life, but the occupants of other vehicles sharing the road. This is exactly why Tesla is pushing so hard to bring full self-driving technology to the Semi. If autonomous driving can reliably reduce human error in one of the biggest and heaviest vehicles on the road, the potential improvement in highway safety could be significant. That said, Tesla hasn't announced an official launch date for self-driving capabilities in the Semi, and there's no indication that fully autonomous trucks will be operating anytime soon. However, the fact that these validation vehicles are already being tested on public roads sends a clear message. Tesla isn't just promoting ambitious ideas. It is actively gathering real-world driving data using production-ready trucks in everyday conditions. The story becomes even more interesting when you look at the latest version of the Tesla Semi. Tesla didn't simply add a few extra cameras and call it an upgrade. The refreshed Semi is equipped with 10 exterior cameras and an additional camera inside the cab. At the moment, these cameras support advanced safety features, such as automatic emergency braking and lane keep assist. But it's obvious that this hardware has been designed with a much bigger goal in mind. Together, these cameras provide the level of environmental awareness required for full self-driving in one of the most demanding transportation applications imaginable. This is also where Tesla separates itself from many traditional truck manufacturers. Other companies can install additional sensors, radar systems, LiDAR, or advanced driver assistance features. Tesla, however, is focused on building a fully integrated system where cameras, AI software, neural networks, vehicle data, and the electric powertrain all work together seamlessly. Instead of relying on separate technologies operating independently, Tesla is creating a unified platform that continuously shares information across every part of the vehicle. For a heavy-duty truck like the Semi, this level of integration is especially important. Autonomous driving isn't just about keeping the truck centered in its lane or maintaining a safe following distance. The system must also manage vehicle weight, traction, trailer movement, regenerative braking, chassis stability, and emergency handling, all at the same time. One technology receiving increasing attention is Tesla's Vehicle Dynamics Control, or VDC. Recently, Tesla Semi program leader Dan Priestley shared a video showing the Semi undergoing winter testing on an icy track in Alaska, where Tesla regularly evaluates the truck's performance under extreme conditions. During the test, the Semi briefly lost traction and drifted slightly away from its intended path before quickly regaining stability. While it may have looked like a small moment, it demonstrated an important capability. For a truck of this size, even a slight slide on ice can quickly develop into a dangerous jackknife situation where the trailer swings sideways toward the tractor. This is one of the most serious hazards faced by heavy-duty trucks during winter driving. Tesla says its Vehicle Dynamics Control system combines high-resolution sensor data with extremely precise control of the truck's multiple electric motors to maintain traction on slippery surfaces like snow and ice. In simple terms, the system constantly monitors wheel speed, steering input, lateral forces, and the truck's overall movement. If it detects the earliest signs of traction loss, it instantly adjusts power delivery to individual wheels or applies selective braking to restore stability before the situation becomes dangerous. What many people don't realize is that conventional diesel semi-trucks handle these situations quite differently. Traditional traction control systems usually react only after wheel slip has already begun. They reduce engine power or apply the brakes to regain traction. Because diesel trucks rely on engines, transmissions, drive shafts, and hydraulic braking systems, those corrections naturally take longer to take effect. The Tesla Semi has a major advantage thanks to its electric drivetrain. Its electric motors can increase, decrease, or redistribute torque almost instantly, making adjustments in fractions of a second. This isn't simply about improving acceleration or performance. It's about maintaining complete control of an extremely heavy vehicle before a small loss of traction develops into a much more serious incident. If one side of the truck starts to lose grip, the system can immediately reduce power to those wheels, redirect torque to wheels with better traction, and combine those changes with precise braking to guide the truck safely back onto its intended path. During normal highway driving, most drivers would never even notice these corrections taking place. But on icy roads, where every small mistake can quickly escalate, this rapid response becomes a major safety advantage. Another important detail from the Alaska test is that the trailer wasn't running empty. According to Dan Priestley, the trailer was carrying a realistic payload that included concrete ballast positioned above the fifth wheel, along with heavy steel bars distributed throughout the trailer. Testing with a loaded trailer provides a much more accurate representation of how the Tesla Semi performs under real working conditions, where weight distribution and vehicle dynamics become far more challenging than they are with an empty trailer. The type of cargo used during the test also deserves attention. The trailer was loaded with materials that have a relatively low center of gravity, making them ideal for evaluating vehicle stability. Even so, the test highlights an important point. Tesla wasn't demonstrating its technology with an empty or lightly loaded trailer. Instead, it chose a setup that more closely resembles real-world operating conditions, allowing engineers to evaluate the system under a meaningful load. Of course, it's important to keep these results in context. The footage was released by Tesla itself rather than an independent testing organization or third-party safety agency. While the demonstration is impressive, no control system can overcome the laws of physics. Factors such as road conditions, vehicle speed, cargo weight, tire traction, strong crosswinds, and even driver actions all influence how a truck performs. For that reason, claims suggesting the Semi can completely eliminate jackknifing should be viewed as an optimistic goal rather than an absolute guarantee. What truly stands out is the engineering behind the vehicle. The Tesla Semi's electric architecture provides several inherent advantages that conventional diesel trucks simply cannot match. Its battery pack is mounted low within the chassis, lowering the truck's center of gravity and improving stability. At the same time, its electric motors can respond almost instantly, allowing torque to be adjusted with exceptional precision. Instead of multiple mechanical systems reacting one after another, Tesla's software coordinates the powertrain and stability controls as one fully integrated system, enabling faster and more accurate responses. Beyond the technology underneath the truck, Tesla has also made several thoughtful improvements inside the cabin. The Semi continues to feature its distinctive center-mounted driver's seat, but the dashboard has been upgraded with two larger 16-inch QHD displays positioned on either side of the steering wheel. The centered driving position has always been a deliberate design decision, giving drivers a balanced view of the road while keeping both displays comfortably within their natural line of sight. This reduces the need to constantly look left or right, helping drivers stay focused during long hours behind the wheel. Rather than emphasizing style alone, the cabin is designed to improve driver awareness and reduce fatigue, an important consideration for trucks that may travel hundreds of miles during a single shift. Tesla even describes the interior as an office on wheels, and several ergonomic improvements support that idea. Cup holders have been repositioned for easier access, storage compartments along the sides have been enlarged, and the steering wheel controls have been arranged so that many common functions can be operated comfortably with one hand. Another noticeable improvement involves the side windows. They now extend farther down into the doors, making it easier for drivers to reach outside the cab when necessary. According to Tesla, this change came directly from feedback collected during early prototype testing, showing that real-world driver experience has influenced the final design. The camera system has also evolved. As mentioned earlier, the production Tesla Semi uses 10 exterior cameras, a reduction from the 26-camera setup found on earlier prototypes. These cameras are mounted lower on the vehicle in positions similar to those used on the Model 3 and Model Y, while still providing the coverage needed to support Tesla's long-term full self-driving plans. Samsung serves as the exclusive supplier of the camera hardware used on the Semi platform. Inside an electric truck, the displays serve a much greater purpose than simply showing information. They function as the central command center for the vehicle, providing navigation, battery levels, energy usage, charging status, live camera views, safety alerts, trailer information, and potentially future full self-driving supervision features. For a commercial truck covering around 100,000 miles every year, an efficient user interface is critical. Even a few extra seconds spent searching for important information can add up significantly over hundreds of thousands of miles. Likewise, if camera views are difficult to interpret, drivers may experience greater fatigue while maneuvering through distribution centers, merging onto busy highways, or operating in crowded ports and freight terminals. That's why Tesla's redesigned cabin isn't simply about comfort. It's designed to improve productivity and maximize vehicle uptime. In the trucking industry, a vehicle generates revenue only when it's on the road. Every hour spent in a repair facility represents lost income for fleet operators. According to Tesla, its growing semi-fleet has now accumulated approximately 13.5 million miles of real-world driving experience. One individual truck has already exceeded 440,000 miles of operation. Tesla also reports that the fleet currently achieves around 95% uptime, with roughly 75 to 80% of service issues resolved within 24 hours. Nearly half of all reported service cases are addressed in less than 1 hour. A 95% uptime rate represents a major financial advantage for commercial transportation companies. The less time trucks spend undergoing repairs or maintenance, the more time they can spend hauling freight and generating revenue. Perhaps that's the biggest shift we're seeing in Tesla's approach to the Semi. When it was first introduced, much of the attention centered on its futuristic appearance, rapid acceleration, innovative cabin, and bold promises to transform the trucking industry. Today, the focus appears to be changing. The latest version of the Tesla Semi is becoming less of a futuristic concept and more of a practical commercial vehicle designed for everyday logistics. Rather than simply showcasing cutting-edge technology, Tesla is steadily refining the Semi into a dependable work truck built to meet the real demands of fleet operators.